Here in the American West, powerful forces have shaped an incredible landscape. The continental upheaval and erosion that created these formations have brought ancient rock beds back to the surface. Rocks that began as sediments 100 million years ago lie exposed once again to the wind and the rain and to the chisel and pick of the paleontologist. Many of these rocks contain the remains of ancient life forms, petrified bones of animals that were unlike anything seen before or since. The remains of one animal in particular are so plentiful and so widespread, it is often said that they ruled the earth, the dinosaurs. This is dinosaur country. Most of what we know about these animals comes from the incredible quarries and digs of the West. The golden age of dinosaur discoveries began in the late 19th century, when paleontologists uncovered huge bone beds in Wyoming, Colorado, Utah, and Montana. Although dinosaurs have been found all over the world, from England to Mongolia, all of them are from places that were warm, tropical, or subtropical environments at the time. Dinosaur comes from the Greek words meaning terrible lizard. It was assumed that, like lizards, they could not survive cold. In fact, a drop in the overall world temperature is one of the most widely accepted theories of their extinction. Until very recently, no extensive evidence of dinosaurs had ever been found in the Arctic or Antarctic, the polar regions of the planet where winter means months of cold and darkness. In 1984, that all changed. Dinosaurs were discovered on the north slope of Alaska. This simple discovery, made almost by accident, would end up changing the way we look at the dinosaurs. The whole adventure began with this mysterious drawer full of bones. They had been sitting in storage for over 20 years. No one had recognized them for what they were. These were dinosaur bones from the top of the world, and they were about to create quite a commotion. Dr. Elizabeth Browers is a paleontologist with the United States Geological Survey, the USGS. She explains how this surprising discovery first came to light.
We had plans before we found out about the dinosaur site to do reconnaissance work along the Colville River for about 2 weeks, helicopter work. And when the Shell Oil Company geologist, because we communicate a lot between industry and USGS, when he realized that we were going up there, he brought these bones to our attention, and the USGS vertebrate paleontologist recognized the bones as dinosaurs. And we became very excited, of course. This was the first occurrence of skeletal remains of dinosaurs that had ever been found in Alaska, and certainly the youngest in the highest latitude. So we were very excited about relocating this site, if possible, and seeing if there were more bones.
It was the search for oil and minerals that brought R.L. Liscombe, a field geologist, to the Colville River in 1961. The dinosaur bones that he collected had weathered out of a cliff along the river. Liscombe picked them up on the narrow beach. He assumed that they were mammoth bones, which were common in the area, but he was about 64 million years off. In 1984, when the USGS re-examined the bones, they got a big surprise. Dinosaurs, not mammoths, and from the North Slope of Alaska. It seemed incredible. From what we know about dinosaurs, they shouldn't have been up there. The mysterious bones were sent to Kyle Davies, a research paleontologist at the Balconies Research Center in Austin, Texas. Davies confirmed that they were indeed dinosaur bones, probably belonging to a hadrosaur, more commonly known as a duck-billed dinosaur. Davies explains how he entered the picture.
All right, I got involved with the Alaskan hadrosaurs because one day, 1984, we got this package from a guy named Charles Repenning. It was sent to Dr. Juan Langston, who at that time was the director of the lab here. And he showed these to me because my interest was in duck-billed dinosaurs. It still is. And we both agreed they're duck-billed dinosaurs, and Dr. Repenning had sent them out here with the idea, you know, I think these are duck-billed dinosaur bones, and they've been found on the North Slope of Alaska. And could you identify them any better? Can you get them down to subfamily or genus or species? But I looked at him and said, hey, I don't know of any reports of dinosaurs at all out of Alaska. That is the upper end of a tibia from the Liscombe collection, our shin bone. And what it basically shows, it's all shattered up and busted, but it shows that there are large duck-billed dinosaurs from that deposit. It's sort of hard to estimate on just one shattered up fragment like that, but they're in the same size range as your other average dinosaur bones from parts of Canada, which would put them about, say, 20, 25 feet long. This is the toe bone of one of the little juvenile hadrosaurs. You can see it in different angles here. To give you sort of a comparison view, this is the toe bone, the same toe bone from an animal from the Big Bend area of Texas. And you can see it again, different angles, how they compare out. One's an adult and one's a juvenile.
The Alaskan bones belonged to some kind of hadrosaur. The exact species was uncertain. Hadrosaurs, or duck-billed dinosaurs, were one of the last great dinosaur families to evolve. These giant plant eaters thrived in North America until the Great Extinction brought an end to all dinosaurs 65 million years ago. Hadrosaurs lived in the Cretaceous period, the last of the three great periods, Triassic, Jurassic, and Cretaceous, that make up the Mesozoic age, the age of the dinosaurs that lasted for 160 million years. Hadrosaurs and other late Cretaceous dinosaurs hold the key to the mystery of the Great Extinction. In the fossil record, the so-called KT boundary marks the end of the Cretaceous and the beginning of the Tertiary period and the age of mammals. This iridium-rich layer of rock, which was laid down 65 million years ago, is found all over the world. Dinosaurs are only found below this layer and never above it. The Alaskan dinosaurs were potentially one of the most important finds of the decade. But at this point, there wasn't much to go on. The paleontologists had to go back to the site to search for more hadrosaur bones. They hoped to find skull fragments and perhaps evidence of other species as well. Dr. William Clemens, a paleontologist from the University of California, Berkeley, would head up the expedition back to the Colville River. He describes the difficulty of mounting a dinosaur dig in the Arctic.
Summer of '86, they had a 3-day blizzard through the area. In terms of tent, sleeping bag, and clothing, I just got to warn you, be ready. We could spend a couple of days freezing together. And if it really gets bad, we can get in the boats and go down to Noixit, which probably a half to 3/4 of a day run. I hope it doesn't come to that.
The logistics were complicated further by the fact that this whole area was a wildlife preserve for the endangered peregrine falcon. To protect the fledglings, there was only a 2-week period out of the entire year when the area could be visited, and bad weather could narrow that window even further. We would fly first to Fairbanks, Alaska, in the center of the state, where we would rendezvous at the university. The equipment would be packed into smaller planes, and the team would head north. The first stop was Point Barrow. For most of us, it was our first trip to the top of the planet, an area at the northern edge of Alaska. And then it was on to Dead Horse. From Dead Horse, specially chartered flights would take us to the Colville River. There were no roads to the dig site. Luckily, the Alaskan bush pilots were experienced at hauling people and equipment in and out of dangerous locations. It was impossible to land a plane on the tundra, and swift currents in the river made a water landing difficult. The pilot's only option was to set down on a large sandbar along the west side of the river. It would double as our campsite. It took several trips to ferry in all the equipment and supplies, including the inflatable boat, which would take us to the dig site downriver.
I think this locality and this river bluff, the 60 miles of section that encompasses 15 or 20 million years, is probably the best bet for finding dinosaur skeletal remains, hundreds, probably thousands of individuals of any place in Alaska. The dinosaurs seem to occur in organic-rich beds, which we are interpreting as soils, and you see them very clearly on the cliffs as dark, coal-looking horizons.
The success of this expedition required the cooperation of a number of organizations: the Museum of the University of Alaska Fairbanks and the Bureau of Land Management, the agency that controlled the region. Additional funding was obtained from the National Science Foundation, and our film crew was allowed to document the historic expedition. When the last of the supplies were unloaded, the pilot wished us luck and took off. The plane would return for us in 7 to 10 days, depending on the weather. Until then, we were totally on our own. It was an instant lesson in survival. We'd have to watch out for blizzards and floods, for bugs and bears. The first order of business was setting up the tents. The weather was changeable, and left unprotected, we could easily freeze to death even in the summertime.
There are a whole variety of people involved here. We've been blessed by having sort of a full-bore U.S. Geological Survey treatment of the area, looking at the pollen, the detailed sedimentology, looking at microfossils, the radiometric age determinations. Survey geologists have been doing this whole variety of things, and it makes this a special case in that with many of our discoveries, we find the bones, find the question, and then have to go find these specialists. Here we're blessed by having all these other kinds of studies either done or in progress, so that they're contributing right now.
The sun never sets at this time of the year in the Arctic. It stays light for 24 hours a day. This shot was taken at midnight. It's almost impossible to sleep, but we'd have to get some rest. In the morning, we would set off for the cliffs down the river. Commuting to work across an icy Arctic river is a strange way to begin the day. Our destination was the world of 65 million years ago. Modern science has explored the three-dimensional world. Through telescopes and microscopes, we've seen the largest galaxies and the smallest atom. We had become explorers of time, the fourth dimension. We were time travelers, with the almost impossible task of recreating the world of the dinosaurs from the few small fragments and traces that had been left behind. Paleontology is a fairly new science. It wasn't until the 19th century that dinosaur skeletons were recognized for what they actually were, a unique type of animal that successfully dominated the Earth for 160 million years. It's an incredible span of time, considering that the oldest human fossils are only about 1.5 million years old. But something mysterious happened on this planet 65 million years ago, and the dinosaurs vanished. We had come this far in search of one more piece in the puzzle. Maybe a clue from the Colville River would solve the riddle and answer one of the most perplexing questions of all time.
Okay, it's one of these almost monospecific bone beds. Almost all the bone and teeth represent apparently one kind of hadrosaur. So it looks as though what we've got is an accumulation, probably one that occurred at one time. The bed itself seems to be one unit. The bones are most concentrated at the bottom, and then as you work upward, you get fewer bones and smaller bones on the average. So it looks like this unit, there may well have been a flood that just picked up a lot of carcasses.
Good luck for paleontologists relies on bad luck for dinosaurs. The best scenario for creating a good fossil skeleton is a sudden disaster, a flash flood, a quicksand pit, or a Pompeii-style volcanic eruption. The sooner that the creature is covered with sediment, the better. The body does not have time to decompose, disarticulate, and be destroyed. Taphonomy is a whole branch of paleontology that attempts to answer the question, how did the bones get here? Often dinosaur quarries are jumbled piles that resemble the remains of a feast. In Africa today, lions, jackals, and vultures can completely obliterate an antelope in a few short days. Carnivorous dinosaurs could probably have done the same thing. They came in all shapes and sizes, a whole food chain of predators and scavengers who could quickly destroy the carcasses of their prey. The dinosaurs have left more than just their bones here in the rock. Experienced eyes look for other traces as well, like gastroliths, believed to be dinosaur gizzard stones. Only an expert would recognize a coprolite, literally a fossilized dinosaur dropping. It's rare, but sometimes a piece of rock or matrix is pulled off to reveal a dinosaur skin impression. This is a dinosaur tendon. And this is the rarest prize of all, a dinosaur egg. When the first egg was recognized in 1923, it made world headlines. It caught the fancy of a dinosaur-hungry public and became one of the most celebrated oddities of the century. It was no surprise to scientists who had suspected that dinosaurs laid eggs. Reptiles, birds, and even some mammals lay eggs. In fact, hard-shelled eggs were one of the evolutionary developments that first enabled animals to colonize the land. It meant that they didn't have to return to the water to breed. The eggshells were hard enough to protect the young while they were incubating, and they were hard enough to fossilize and remain preserved to this day. Researchers at BYU have applied some high-tech methods to studying these ancient fossils. A CAT scan was used to peer into the interior of the world's oldest dinosaur egg. Amazingly, the scan revealed the embryo of a tiny, unborn dinosaur. Even though the Alaskan site contained the bones of very young dinosaurs, it probably would not contain any eggs. Dr. Browers explains.
Where the bones are preserved is a lowland locality. These are all, this is a delta plain with a lot of small ponds and distributaries and meandering waterways. Very waterlogged, very marshy, no trees on the delta. And it's not the kind of environment where dinosaurs lay eggs. All of the work that Jack Horner has done has indicated that the mothers laid eggs, have the nests in the highlands. And then the animals moved down to the lowlands to feed. And so we wouldn't expect in this environment to find the eggs.
Jack Horner is a paleontologist who gained worldwide attention for his discovery of a complete hadrosaur nesting site in the mountains of Montana. There was evidence that the hadrosaurs had returned to the same site every year to lay their eggs. It was an incredible find, part of the growing evidence that dinosaurs may have had a complex family life. The site on the Colville River was probably not a hadrosaur breeding ground, but rather a feeding ground. Not surprisingly, the most common fossil found was a hadrosaur tooth. The hadrosaurs had hundreds of teeth, all growing at once and being constantly replaced. They had evolved one of the most massive dental systems ever seen. Kyle Davies, a hadrosaur specialist, explains their curious dentition.
To me, the real special thing about hadrosaurs, or their special development, is their tooth batteries. Now, all dinosaurs had a thing known as continuous replacement of the teeth. Famous dinosaurs like Tyrannosaurus rex had this also. They had, as each tooth came in, got worn, it pops out, and a new tooth comes in and replaces it. Now, hadrosaurs took this one stage further. They took all of those teeth and they tightened them up into a nice tight battery, so that each tooth links together like bricks in a tile. And they increased the number of generations coming out so that in the most advanced forms you find, the very latest Cretaceous hadrosaurs, they had something like 5 to 6 generations of teeth, all going at once as you go down this battery. This meant that the duck-billed dinosaurs had this very efficient grinding battery, top and bottom.
The duckbills could eat practically anything. It was an evolutionary edge that allowed them to survive the dark winters. When all the plants had dropped their leaves, the hadrosaurs could exist on root systems. They could even eat wood, conifer needles, and other marginal vegetation. Months later, in the lab in Berkeley, an almost complete skeleton of a juvenile hadrosaur was assembled from the bones taken from the Alaskan site. We know how they looked. What we want to know is how they lived. Kyle Davies paints a lively picture of the late Cretaceous hadrosaur.
There's a classic work by two guys named Lowell and Wright. It was written in 1942, where they reviewed everything that they could find out about North American duck-billed dinosaurs to that date. And one of the things they suggested about them is that the duck-billed dinosaurs were like the modern moose. A moose is a large herbivorous mammal, and it runs around out in the woods there in the northwest, munches on the trees and stuff. But it'll also just plunge right out into the waters and munch on the soft water growths and just chug them down by the tons. And it'll swim around in the lakes. It'll run out onto the shore. It does all of these things. It's an amphibious type of creature. It's, in the true sense of amphibious, it's happy both on land and in the water.
All the theories, all the facts. Everything we know about dinosaurs starts here in the field. This is where the bodies are buried. The paleontologist covers a lot of ground and comes face to face with present-day nature in the search for the past. Mark Goodwin knows the routine better than most. This veteran dinosaur hunter from UC Berkeley has put a lot of mileage on his hiking boots searching for the elusive beasts.
A paleontologist works in the field, does a lot of walking. Knowing where to dig is basically recognizing different sediments and knowing where bones are found in a particular area. So we do a lot of walking. We probably do as much walking as we do digging. And once we see an area that appears to be fossiliferous, or bone is weathering out on the surface, collecting in small pockets, we'll then trace this bone, known as float, that appears on the surface, and try to see where it's coming from, where it's weathering from in place in the sediments.
we often split up into smaller groups to go off and explore other localities. The formation that contained the dinosaur-rich beds could be followed up the river for miles. The weather was perfect. It wasn't snowing or raining or too windy. Low temperatures the night before had killed the mosquitoes, or at least temporarily stunned them. In the perpetual daylight of summer, the Arctic can be quite beautiful. Only a foot beneath these plants lies the permafrost, ground that is frozen year-round. But on the surface, an incredible variety of life manages to thrive. Testimony to the power of plants and animals to adapt to even the harshest conditions. Out here in the tundra, away from the safety of the camp and 100 miles from the nearest payphone, we had to watch out for ourselves. No one went out alone without carrying a special survival kit. We had nothing to fear from the dinosaurs, but we had to deal with a predator of our own era. The best defense was just to announce your presence with a blast from an air horn. It was loud enough to scare away most bears, and it was also a call for help. We carried whistles for the same reason and wore bells on our clothing. The grizzlies had extremely good hearing. A gun was only used as a last resort. As paleontologists, we were painfully aware that the human race has caused more than its share of extinctions. Luckily, we didn't have any problems on this trip. The bears and the falcons kept to themselves. There was plenty of room out in this big country, and the animals barely noticed us. We were just colorful dots in a vast landscape. As the vague shapes emerged from the rock, the trained eyes of the paleontologist recognized dinosaur vertebrae, hip bones, and ribs. Bill Clemens would like to offer a word of caution, however, to anyone who might spot some bones like these and be tempted to haul them back to their local museum.
From our viewpoint, it's so much better if a person comes here and says, "Hey, I found a bone. Will you come out and look at it?" Rather than trying to grub it out of the ground and bring in the gunny sack full of pieces and you say, "Oh my gosh, once it was good."
Here at the Colville, time was limited and the paleontologist wanted to remove as many bones as possible. Roland Gangloff, curator of earth science at the University of Alaska Museum in Fairbanks, demonstrates the correct way to prepare a fossil bone for its trip back to the lab. First, the surrounding rock or matrix is removed. The bone is left standing in place on a pedestal of underlying rock and debris, often other bones. If the bone starts to crumble, it's fixed on the spot with Glipdol or Egyptian glue. It's important to record the bone's exact position in the matrix and to study other bones that are nearby, as they may be related or even connected to the one being removed. After the bone is covered with moistened tissue or paper towel, a plaster cast is created. It's similar to a cast that a doctor would use to set a broken leg or arm. Splints are often used to keep the fossil in one piece and provide additional support. This particular bone is from an adult hadrosaur. plaster cast takes about an hour to dry. Then the fossil is flipped and the entire process is repeated on the other side. We only had one shot at these particular bones. By next year, they would most likely be buried again by the collapsing bluffs, washed away by the changing course of the river, or destroyed by the Arctic weather.
As the fossils wear out, they're lost forever. That information is lost, and they're relatively rare. The fossils are a resource that should be protected, should be collected, and properly curated and studied. One can collect more material than one can possibly study in a small period of time, but it's important to maintain collecting efforts.
It might take years, but the ultimate goal of the paleontologist is to completely recreate the world that existed 65 million years ago, to discover all the different types of dinosaurs that were present here, to analyze the plants, the climate, and the overall environment of the time. The Arctic dinosaurs were unique, a new chapter for the textbooks, and a new snapshot in the ancient history of our planet.
Okay, in terms of geological vision, if you're looking at one snapshot taken every 10 million years, then clearly you're getting pictures of sort of jerky change. Now, if you start putting in a picture of the fauna or flora taken every million years, you're beginning to smooth it out, or identify areas where you do have abrupt change. And right now, I think we're sort of in this transitional period, if you will.
The bones are only half the story. The rocks contain the fossilized remains of much smaller creatures as well, ancient microscopic organisms that can give more detailed information on the environment of these dinosaurs. Dr. Browers specializes in these microfossils and did an extensive study of the Colville site.
I found a very high species diversity, a very large number of species of microfossils. The group that I work with, ostracods, are aquatic, and they occur in freshwater, brackish water, and in marine environments. And all three of these environments are represented at the locality in the Colville. And unlike the dinosaurs, the microfossils are a little more specific. And so you find one type of species in a pond and another type of species in a river. And because these sediments represent a variety of environments, I found, in fact, quite a large number of species representing all of these different environments. But the bluffs are so steep and so unstable that any attempt at excavating a three-dimensional surface is very, very dangerous. Wherever I took my microfossil samples, I dig back and try to get nice fresh rock. And almost every place where I dug had bluff collapse the next day, and sometimes the bluff collapsed right after I moved away. It's really can be rather treacherous.
Fossil plants and pollens provide even more clues to the climate of the area at the time of the dinosaurs.
As best I understand it, the paleobotanists are telling us that this was not tropical at all in type of plants. That the plants you're seeing are more typical of what you'd call a temperate type environment. Middle United States would be middle United States right now. So the average temperature year-round would have been cool, but not necessarily severe, as you have it nowadays, where the Arctic Ocean is ice-bound.
The Arctic hadrosaurs lived in forests similar to those that you might see today in the Pacific Northwest or parts of Alaska. It was previously thought that no dinosaur could survive these temperate to cold conditions, especially when the dark winters set in. It posed an important question. Were the Alaskan hadrosaurs only seasonal visitors to the area? Did they migrate south for the winter?
If they migrated, then presumably they would be migrating to get away from the darkness and to go to a place, a region where there was permanent vegetation, year-round evergreen vegetation. And you would have to go from the North Slope at 70 degrees almost to the U.S.-Canadian border before you hit permanent evergreen vegetation. And that is a long way for an animal that's less than a year old, even as fast-growing as the hadrosaurs are. That's a long way for that animal to move, to migrate in 1 year. A juvenile duck-billed dinosaur can grow up to 3 to 6 feet in 1 year. So 6 feet, now that's a large animal, but it's still very small relative to the adults. And migrating down from Alaska, the north slope of Alaska, all the way down to Montana, is moving very fast.
Were the dinosaurs capable of traveling such distances? Most people don't know that dinosaur tracks actually exist, but there are a number of sites like this around the world. More than 70 million years ago, a herd of dinosaurs came strolling down the banks of a river and left their footprints in the mud. The mud hardened. Covered by layers of sediment, it eventually fossilized. Erosion reversed the process, and the modern-day river exposed the layer of rock containing the footprints. We can match these footprints with fossil foot bones to identify the species. By examining the length of the stride, taking into account the size of the individual, we can tell how fast they move. We know that many plant-eating dinosaurs travel in herds, sometimes with their young in the center of the group for protection. Some trackways show ruts where the dinosaurs had dragged their tails. It appears that they moved rather slowly, but were capable of short bursts of speed. The late Cretaceous hadrosaurs had an extra advantage.
If you look at them, they've got expanded feet, and some of the footprints show traces of webbing, not extensive duck foot type webbing, but just connecting the toes up and making the whole foot pad broader and more expansive. And the tracks that we have of duckbills, they're rare, but we have them, show this very broad foot.
They were probably good swimmers and might have fled into the water to escape their land-bound foes, the tyrannosaurids. Their tracks are here as well, and the trackways tell a dramatic story of predator and prey. These meat-eating monsters left their three-toed footprints in the mud as they were stalking the herd or actively attacking. One trackway even shows the signs of a scuffle. Some tyrannosaurs were apparently very fast. Larger individuals may have been capable of speeds of up to 30 miles per hour. The sharp claws on their hind legs left distinctive impressions, the same claws they used to rip apart their prey. The Alaskan hadrosaurs had to deal with predators as well. Evidence comes in the form of isolated teeth. One tooth is all that was needed to prove that these carnivorous dinosaurs were in the Arctic as well.
Now, there are teeth of two other forms. One is Truodon. The other one, which again is represented by isolated teeth, is some kind of tyrannosaurid. The composition of the bone accumulation is not unique. Similar things have been found in Alberta. You tend to get a lot of bones of one kind of animal. And then the teeth of forms that may have been predators are more likely scavengers on the carcass. And there the teeth get knocked out of these animals we're eating.
These are the bones of a small dog-sized carnivore from Alaska. Were the dinosaurs cold-blooded, like lizards, sluggish and unable to survive the cold weather? Or were they warm-blooded, like birds and mammals, more active and able to adapt to harsh environments? Robert Bacher, author of the book The Dinosaur Heresies, believes that the Alaskan dinosaurs validate the theory of a warm-blooded dinosaur.
Well, the Arctic is a good test case of a lot of theories because the Arctic, without question, was the coldest known sampled environment in the late Cretaceous, with at least 4 months of rather severe cold stress. Not like today, of course, but severe compared to the tropics. We already have a pretty good idea of the plants. A lot of them were deciduous. If dinosaurs were really sensitive to the cold, as some people claim, you shouldn't find as great a variety of dinosaurs up there. The fact that you have a lot of big dinosaurs running around in a climate like Seattle's in the Cretaceous in the Yukon is very powerful evidence that they weren't simply cold-blooded critters. They weren't large versions of tortoises and crocodiles. No matter how you cut a dinosaur, it doesn't look like a lizard or a giant tortoise. If you literally cut those North Slope bones, and we actually have a few fragments here, the texture of the bone indicates extremely rapid growth, which is typical of all dinosaurs. The overwhelming evidence, there's thousands of pieces of evidence, from dinosaur bone texture is that these things had emphatically a warm-blooded bird or mammal style of growth.
It was time to leave the Colville. A mysterious drawer full of bones had brought us to the top of the world where we had discovered a whole array of Arctic dinosaurs. A first. The expedition was ending, but the controversies were just beginning. These hardy dinosaurs survived the darkness and cold every winter. It was tempting to speculate. Could they have survived the extinction as well, living on for a while into the tertiary age of mammals?
This Colville sequence that we work in, Colville group, the oldest beds in there are late, early Cretaceous. The youngest are Cretaceous tertiary boundary. Terms like that are defined on characteristic suites of animals and plants. And there's nothing characteristic about what's up in Alaska, because it's becoming clearer every year that high latitude faunas contain some very bizarre selections of animals and unique species.
I wouldn't be overly surprised to find that some dinosaurs may have gone right into the basal tertiary. I don't think it's been demonstrated, and I think it will be a marginal population that, if anything has made it, it'll be a population in the Arctic or the Antarctic. But I don't think our dating is good enough at this stage to absolutely determine that. And I found from the Cretaceous all the way to as young as 5 million years ago that there always seems to be a controversy about the age of the sediments. It's not easy to get a consensus based on 2 or 3 different fossil groups. This is what the age is. I'm involved in 2 very controversial age issues that I think are fairly straightforward, but another fossil group has said, no, you're 20 million years off. And that's quite a bit of time.
It's difficult to give an exact date to fossil beds, but the question of whether the Alaskan dinosaurs, or any dinosaurs, survived the Great Extinction may be academic.
When dinosaurs became extinct at the end of the Cretaceous, why? Well, obviously, we define the end of the Cretaceous by the last record of dinosaurs. It's no surprise that they all become extinct at that time. And in many areas of the world, you don't have a pollen record, you don't have an iridium record, you don't have a magnetostratigraphic record. You're defining the end of the Cretaceous by the last dinosaur.
On the last day of the expedition, Dr. Howard Hutchinson had uncovered the entire skull of another species of dinosaur, a ceratopsian. All the work that remained to be done would take place back at the lab. The skull, identified as a Pachyrhinosaurus, went to Mark Goodwin in Berkeley for preparation.
Well, the Alaska material, the preparation is completed back here at the lab in Berkeley. We open up the jackets that we collected on the North Slope and let the bones dry out. And the jackets, when the bones come back to the lab here, and they're, of course, wrapped in these plaster jackets, protective jackets of plaster bandages or burlap and plaster, we open them up and let them dry. The jackets are very moldy, they're damp, the bone is still quite soft. So we let them dry out, and then we will soak the bone with a dilute solution of Vinac, this hardener that I mentioned earlier. Polyvinyl acetate B dissolved in acetone. We'll thoroughly soak the bone. And when this is done, the bone retains its hardness, and we can remove it from the jacket, remove the mud and sand and debris, or matrix as it's called here. Remove that from the bone with various tools and instruments in the prep lab. We have various hand tools and pin vices with carbide rods. We use smalley or abrasive machines that remove the matrix and leave the bone exposed. And it's a slow process, but once the bone is dry, things go fairly quickly. There's a locality number given to the bone, actually written right on the bone. Locality number for the quarry that the bone came from. There's also a museum number, or a specimen number. Every bone in this museum is cataloged, much like a library book on a library shelf has a number. So the actual individual bone is given a separate number, and this is cataloged onto the computer now, where all the pertinent locality information, identification, formation it's from, collector, date of collection.
The ceratopsian skull from Alaska was from a dinosaur of the same family as Triceratops, the famous three-horned plant eater that roamed Western America during the late Cretaceous. Our portrayals of dinosaurs are becoming more and more accurate, but there are some things we may never know. What color were they? What was the significance of the bizarre head ornamentations? How intelligent were they? Research paleontologist Mike Greenwald from UC Berkeley thinks that we can answer some of these questions by examining modern-day animals.
Let's take a look at a big carnivorous animal that lives today in a forested environment, a tiger. It's striped, so the stripes break up its body outline, so it can creep up on water buffalo or whatever it's going to eat. And Tyrannosaurus, likewise, was a big carnivorous animal living in a semi-forested environment, so it may have been spotted and slashed and whatnot to hide it, camouflage it as well. But there's really no way of telling. These are obviously gregarious animals, lived in great herds. You take a look, you ask the question, why were there so many ceratopsian frill types? And why were there so many hadrosaur crests and whatnot? You take a look at the Serengeti Plain today, with the vast numbers of antelope, the strange kind, kudus and impalas and whatnot, all these strange types of curled and straight and curved horns, and you wonder why, what's the necessity? Well, species-specific recognition. You live in a herd, you've grown up with a certain kind of horn, your parents have it, all your siblings have a certain kind of horn, and you get jumped by a lion and the herd scatters. How do you find the herd you belong to? You look around until you find the right kind of horn. It's just visual contact. I was once asked the question, if I saw a dinosaur today, what sound would it make? I simply said, you hear it every morning. Birds are dinosaurs. The smallest dinosaur that ever lived is a hummingbird. This is a study of comparative anatomy, and when you study the anatomy of birds and the anatomy of these small theropod dinosaurs, you can see they're essentially very, very close, if not the same types of animals. If birds were not alive today, they would just be considered to be a weird form of feathered dinosaur, which in fact they are. So we're looking at animals that were at least as intelligent as some very intelligent birds today, like, for example, parrots and birds like that are very intelligent. So these dinosaurs must have been equally intelligent and probably had very complex specific behavior. I mean, I've been bonkers about dinosaurs since I was 4 years old, just like any kid today, and I still am. But it's a bigger picture than just the dinosaurs. And see, dinosaurs lived in a relatively modern world. We had bees and flies and snakes and lizards and mammals and mangolias and, you know, and the various, I mean, if you went into a late Cretaceous forest, you would see something you could relate to, something that would be real in today's world. And there's a whole lot of, there's a vast number of other animals that are living in that forest. And many of them, in fact, most of them, at least at the familial level, are still alive today.
But today, one animal is conspicuously absent: the dinosaur. What happened? What killed them? What catastrophe ended the dinosaurs' 160 million year reign as the dominant land animals on the Earth?
That's a really tough question. It's one of these things that's been debated for a long period of time. Right now, there are two basically current theories for it. One's a climatic type, that the climate at the end of the Cretaceous was deteriorating and dinosaurs couldn't cope with the deterioration. One thing you do see that sort of supports this is the inland seas that have been prevalent during large parts of the Upper Cretaceous were retreating off the continents. The other theory is that a large asteroid impacted the Earth and injected large amounts of dust into the upper atmosphere. This would cut off sunlight and cause the plants to quit photosynthesizing. The plants then would not producing the food that the animals depended upon, and the animals would essentially die off, with the exception of those that are able to manage a sort of scavenging type existence on what little remains. And there's a large variety of evidences now worked to support both sides of the question, and it's still highly debated what's really going on at that point.
The debate is likely to continue. Discoveries such as the one in Alaska point to a new image for the dinosaur, an active, intelligent, adaptable creature, an animal that pushed its domains to the ends of the earth, even to the Arctic. Dinosaurs were the dominant land animals on this planet for 160 million years, and then suddenly they were gone. During the Mesozoic age, they evolved, adapted, and became entrenched in every area of the earth, every available ecological niche. Late Cretaceous hadrosaurs, like those found in Alaska, were perhaps the most highly evolved of all, and yet they too were swept away in the Great Extinction. These ancient bones, in a long-forgotten museum drawer, paved the way for this expedition and led to the amazing discovery of an entire population of Arctic dinosaurs. Paleontologists must return to the Colville River to examine older formations. The more we can learn about the world of the dinosaurs, the greater the possibility of preventing our own extinction. Each new find, each new theory brings us one step closer to the preservation of our own species.
Pasiquatas, Triceratops, Pterodactyl, Seismosaurus,